In this video, you will learn about the definition of similar, and in particular, we're going to focus on similar triangles and being able to identify them from a diagram. So to begin, the definition of similar means two figures that have the same shape, but not necessarily the same size. So again, they're figures that have the same shape, but not necessarily the same size. The notation for similar looks like this. Now, whenever you see that similar notation, this means that two figures are similar, not congruent. So a lot of times people kind of confuse the two. So it's really important that you know the difference between the similarity symbol and the congruent symbol, because if you were to mistakenly write one over the other, it would be considered incorrect. So similar figures can be created in one of two ways. The first one is called a dilation. A dilation is an enlargement. So you may see this vocabulary word used in the textbook a lot. The other way similar figures can be created is through a reduction. A reduction is the exact opposite of a dilation, so it's getting smaller. For similar polygons, there are two things that you need to know. All corresponding angles in similar polygons are congruent. So this is no different than congruent figures. We know that congruent figures, their corresponding angles are congruent, just as well as similar polygons, their corresponding angles are also congruent. Now, the part that makes it different from a congruent polygon is that the ratio of their corresponding sides are congruent. Okay, so the ratio of their corresponding sides are equal. So their corresponding sides are not necessarily going to be equal, but if we were to put their corresponding sides in ratios, those ratios would be equal. So something that you always need to remember, whenever you have similar polygons, the first thing I'd like you to do is start by writing something called the extended proportion. So the extended proportion is just a fancy name for the ratio of the corresponding sides. So that ratio I mentioned in number 2, the fancy name for that is an extended proportion. So anytime you are given that two triangles are similar or two figures are similar, I want you to begin by writing out the extended proportion. So writing out that ratio of their corresponding sides. So here's kind of an example of that. So notice that we're given that triangle ABC is similar to triangle XYZ, so similar symbol, that's what I mean by that. So I would want you to first start by writing the extended proportion. So again, the order of the letters does matter with similar polygons. Their corresponding angles must line up, and so therefore their corresponding sides must also line up. So if we look at this, we know that AB and XY are corresponding sides, so we're going to put those in a ratio. So AB over XY, the ratio of AB over XY is equal to the ratio of BC over its corresponding side, which would be YZ, which is going to be equal to AC over XZ. So this is the extended proportion that I'm talking about. So always start by setting up that ratio. Now I want you to think about the next question for just a minute. Are congruent polygons similar? Why or why not? What do you think? Hopefully the answer you're thinking is yes, they are similar, because by definition of similar, they are the same shape but not necessarily the same size, but they could be the same shape and the same size because they would have a ratio of 1 to 1. Their corresponding angles would be congruent, and the ratio of their corresponding sides would just be 1 to 1. So yes, congruent polygons are also considered similar. Okay, so I'd like you to take the next few minutes and we're just going to kind of practice identifying similar triangles from a diagram. So this is kind of tricky at first, but once you get the hang of it, it's not too bad. So we're going to do this first example together, and then I'm going to have you pause the video and try the next few examples on your own. So for this diagram, we're given that NB, segment NB, is parallel to VR because we have those parallel tick marks. And we want to identify which triangles in this diagram are similar. Well, we know that by definition of similar, that the corresponding angles are congruent and the corresponding sides have that same ratio, but not necessarily the same size. So first we're going to figure out which angles in the diagram are congruent. So since those two lines are parallel, if we look at transversal NS, we can determine that angle ONW is congruent to angle TSW because those are a pair of alternate interior angles. If parallel lines, then alternate interior angles are congruent. Then we know that the vertical angles are congruent to each other, and therefore the last set of angles has to be congruent. So when you go to write out the similar triangles, the order of the letters does matter. So it is important that you put the letters, corresponding letters, in order. So if I call that first triangle, triangle NOW, is similar to, angle N goes with angle S in the other triangle. Angle O goes with angle T, and then angle W goes with W. So that would be how you would write it. Triangle NOW is similar to triangle STW. So go ahead and I'd like you to pause the video and try examples 2 through 5 on your own. See if you can identify the similar triangles based on the tick marks given from the diagram. And then when you're ready, go ahead and press play to check your answers. Okay, so let's check our answers. For number 2, you should have that triangle AED is similar to triangle CEB. Now again, it doesn't have to be written in that exact order. You just need to make sure that A and C are lined up together, E and E, and then D and B go together. In number 3, I have that triangle BCD is similar to triangle ECA. And if we continue on, number 4, I have that triangle SWZ is similar to triangle SXY. And then number 5, triangle MNO is similar to triangle QPO. Hopefully now you have a better idea of how to identify similar triangles from a diagram. It's going to be very important that you put the letters in the correct order so that corresponding angles and corresponding sides are lining up just like we did with congruent polygons. So go ahead and move on to the next video. We're going to talk about a theorem and some other examples of similar polygons.